Hi dear children, how are you all? Hope all are fine and doing well. Children, in our last module, we started domestic electric circuits. And today we will be continuing the same topic, and this will be the last module of this chapter. So let's start our topic. Children, we already seen in our last module that in domestic circuit we are using three wires. They are live wire, neutral wire and the earth wire. Different appliances are connected across the live wire and the neutral wire in parallel connection. There are two safety measures generally we use in our domestic circuit, and they are earthing and electric fuse. We learned about earthing in detail in our last module. Today we will discuss about electric fuse. Electric fuse is a safety device used to prevent damage to the appliances and the circuit due to excess current flow. It is connected in series with the live wire or with the appliances in an electric circuit. It works based on Joule's law of heating. If the current exceeds the limit, the fuse wire melts off due to the heat produced and thus break the circuit. An electric fuse wire made up of an alloy of tin and lead and has high resistance and low melting point. This you already learned in chapter 1, that is in electricity, related to heating effect of electric current. Nowadays, we use MCBs, that is miniature circuit breakers, instead of fuse wire. These are switches which automatically turn off if the current exceeds in the circuit. You can see here the picture of a cartridge fuse which generally using in different devices, and also you can see the picture of a MCB, that is miniature circuit breaker.
Electric fuse. Fuses are safety devices to protect the circuit from any kind of short-circuiting. The fuse wire is of high resistance and low melting point. This fuse wire melts at high temperature developed due to high current, breaking off and thereby protecting the circuit. The fuse wire is made with an alloy of lead and tin, and its thickness measures the current it can carry. In order to safeguard a circuit, the fuse wire used is independent of its length, but is dependent on its cross-sectional area. That is, cross-sectional area of the fuse wire used must always be small. When electric current in a circuit increases beyond the safe limit due to some short circuit, and if no fuse wire is used, excessive heat will develop in the circuit, thereby damaging the home appliances. If a fuse wire is introduced in the circuit, the fuse wire melts since it has low melting point. Hence, the home appliances are saved from damage. Electricity, hazards and safety measures. Hazards. The causes are poor earthing arrangement, shock due to current in the body of the appliance, overloading, short-circuiting, poor quality of insulation of wires used. Safety measures. To avoid shocks from electrical appliances, use proper earthing arrangement. To avoid damage from overloading, do not operate large number of high-powered appliances simultaneously. To avoid damage and fire from short-circuiting, use good quality wires coated with PVC. Replace old, worn-out and damaged wires with new set.
Children, we already seen that we are using two safety measures in electric circuit to prevent excess current flow. Now we will discuss what are the main reasons for this excess current flow in an electric circuit. The first reason is short circuit. Short circuit is the touching of the live wire and the neutral wire when the insulation of wires is damaged or there is a fault in the appliances. As a result, the resistance of the circuit becomes small and a large current flows through the wire, producing high temperature, and due to that fire may break out. The second reason is overloading. Overloading can occur due to different reasons. The first reason is when the live wire and the neutral wire come into direct contact, or it is short circuit. The second one is the accidental hike in supply voltage. The third one is by connecting too many appliances to a single socket. So these are the different reasons for causing overload in an electric circuit. So overloading and short circuit are the main reasons for excess current flow in an electric circuit. So to prevent that only, we are using electric fuse and earthing as a safety measure.
Overload and short circuit are very commonly heard faults in circuit systems. So let's explore in this video what these mean. So let's start with overload. Overload. So what does this word mean? Well, it kind of tells you that there's too much of something, right? Overload, too much of something. So in electronics or in circuits, the word overload kind of means too much current. Too much current. And why is that bad? Why is it bad to have too much current? Well, let's look at a typical household circuit. We have already seen that there are live wires and a neutral wire and a ground wire and everything. We've talked about this in previous videos. Now, every wire has a certain capacity to withhold current, a certain capacity of the current that can flow through it. If the current exceeds that particular value, then what happens is that the heat generated will be too much, the temperature will start increasing, and because of that, a lot of bad things can happen. Like, for example, the insulation of these wires can start melting off, exposing these wires, and those wires can start touching other wires. It can be very bad. And in the worst case, it can even catch fire. So too much current causes too much heat, which can cause fire. And that's why overload is very, very bad for us. So basically overload is too much current. And how do we ensure that doesn't happen in our circuits? Well, you may have all seen about this. That's the whole idea is using a fuse. A fuse is basically a wire which has a high resistance and a very low melting point, which ensures that the fuse wire starts heating up first and melts first. So if the current exceeds a particular value, before these wires, start feeling the heat, literally, before these wires do that, it's the fuse wire that will melt and immediately cut the circuit. Break the circuit. So ensuring that all our devices are, all the wires and the devices are safe. All right, so that's basically how overload protection pretty much works in the most basic terms. And of course, today we also have something called circuit breakers, which is a little advanced version of the fuse. You see, the fuse, once the wire melts, you'll have to change the fuse wire, right? So it's a headache. But with circuit breakers, automatically it breaks the circuit as a switch. It works on a similar principle, but a little advanced. We'll not talk too much about that. Okay, so we understood what overload is, but the question could be, what causes this overload, right? What causes too much current to flow in our circuit? Well, there could be multiple reasons for that. So one of the reasons could be, so let me just write that down over here. One of the reasons that causes too much current is basically too much voltage. Too much voltage. What does that mean? Well, we've already seen that the typical value, the rough value of the voltage between the live wire and the neutral wire in India is about 220 volts, right? That's supposed to be the voltage, and all your devices are designed to work on that voltage. However, sometimes, due to certain, certain things, like, maybe there is a lightning strike, or there is suddenly a huge magnetic field comes in, or some static electricity, something, right? Due to something, voltage can suddenly increase. We call that as a voltage spike. So if a voltage increases in the circuit, immediately all the current in the circuit will start increasing. So that's one of the ways in which overload can happen. And again, fuse protects us from such voltage surges. Another way in which an overload can happen is, there is not too much voltage, nothing is happening when it comes to voltage, but we could be using too many devices. Too many devices. What does that mean? Well, we've all been there, right? That one plug point is not enough for us, so what do? We attach an extender, and then we start attaching too many devices to it. Now, each of these devices is drawing some current, and therefore the total current drawn in the circuit starts increasing, right? The more devices you attach, the more current it gets drawn, and again, eventually the same problem can happen. If the current drawn is just too much, it's more than the capacity of this, then we say there's an overload happening. So this time the overload happened because too many devices were attached, and that's why it's always advisable not to do this. In fact, in a lot of books and a lot of people will say this is what we call as overload. Okay, attaching too many devices, many people will say that's basically what overloading means. But this is just one of the ways to overload. Okay, overload is a very general term, All right, another way of having overload or of getting overload would be to create something called a short circuit. Short circuit. Again, you may have heard of this word. What does the word short circuit mean, right? In short, it kind of means you're creating a low resistance path. Low resistance path. This usually happens when the wires start touching each other. So let me tell you what it means. Now in this particular circuit, let's say we attach some device over here. Then the current starts running this way, right? There'll be a current running from here. It'll go through the device, it'll run through that device, and it'll come back from here, let's say. This is the normal condition, normal path of the circuit. But now imagine somehow the live wire and the neutral wire, they lose their insulation and they start touching each other. Let's say something like this happens. Okay? Let's say, let me zoom in over here. This is where they have lost insulation and the wires are touching each other. Now notice, there is a path from the live to neutral over here. Current can flow like this. And the resistance from here to here is extremely low, right? And so what we have now done is created a short circuit. We have created an extremely low resistance path to go from here to here. In such a case, most of the current will now flow from here to here. So you know what's going to happen? Instead of current flowing this way, almost all the current will now start flowing this way. And now why that is bad is because if the resistance is very low and you have a pretty high voltage of 220 volts, that means the current in this is super high. It can be in terms of thousands of amperes. So the current is going to be pretty strong. And again, we're going to overload our circuit. Too much current is overload. And again, it's the fuse that helps us protect against that. And of course, this short circuit can happen anywhere. Like for example, imagine you attach some device over here. Okay, you attach some device over here, and let's say we have two wires coming in. You actually have three wires coming in. There's also a grounding wire, but I'm ignoring the grounding wire. But again, the same fault happens inside this particular wire. Let's say the two wires start touching each other. Then again, there is a shortcut. Let me get rid of this short circuit. Okay, let me get rid of this short circuit. So now a short circuit is created over here. Now again, the current, instead of flowing all the way through the device, the current will just flow from here to here. Right? Again, a short circuit. And again, that's bad because, too much current, too much heat, it can damage this device. All right, are there other ways of creating short circuit? Yes. You may know water can cause short circuits. So what's happening over there? The idea is, imagine you have some circuit, and again, let's say this is the normal path that the current should take from here to here, let's say. Now, if there's a lot of water and the water has salts, then that water is conducting. So now there's a path available from here to here. There's a path available from here to here, for example, see? And these are all extremely low resistance paths. That means a very high current can start flowing from here to here, right? That's an abnormal current. And so again, that's bad because that can heat things up. And if there are microchips over here, those microchips can easily melt and they can stop working. And that's why when you throw your phone inside water, if the phone is switched on, if the current is running, it's pretty much a goner, mainly because the water creates a short circuit. So that's pretty much it. Let's quickly recall what we just learned. So can you recall what is the meaning of overload in electrical circuits and why is it bad? Then how does overload happen? What are the different ways in which overloading can happen? Can you explain what a short circuit is now? What is the meaning of the word short circuit? Can you explain that to, say, a friend? And finally, can you explain what protects our circuits from these faults of overloads and short circuits? Do try answering these questions, and if you have some difficulty, feel free to go back and watch the video again.